All right, everybody. This is the 8.1 video on doing some graphing of quadratics. So we've been working with quadratics the last unit, and we did some factoring. And so now we kind of want to graph them and see what they look like. So today we're just going to kind of focus on the basics, identify the characteristics of a quadratic, and kind of look at some pictures and what they look like. So real quick, here we want to graph y is equal to x squared. And so I'm just going to make a little quick xy table. Then we'll put a little graph on here as well. So we have x and y. All right, so if I plug in a value 0 in for x, I get y is equal to 0 squared, which is just 0. If I plug in 1, I get y is equal to 1 squared, which is also 1. If I plug in -1, okay, now think about this one. You have y equals -1 squared. So you have y equals -1 squared. And think about what -1 squared is, right? This is -1 2 times. So it's -1 times -1. The two negatives are going to cancel out and end up with a +1. Okay. And you can do the same thing with 2. You have 2 squared, which is 4. -2 squared, which is also 4. Okay, because -2 times -2, negatives will cancel out and you get +4. So this is your little table. And so now we can kind of graph this out here. And if I draw a little there's my y-axis, here's my x-axis. Okay, I don't need the negatives. You can see how here all my y's are bigger than 0. So now if I'll put some all right, so 0, 0 goes here. It's different colors so you can see it a little bit better. Okay, and then we have 1, 1 and -1, 1. Then we have 2, 4. So 1, 2, 3, 4. And same thing on the other side. Okay, and if I kind of connect these together, you get a graph that looks like this. Okay, something like this. Now, I want you to think about a couple of things. Think about the domain and range of this function, of this graph. Sorry, the domain refers to your x's. Your range refers to your y's. So when you look at domain and range, you want to think: is this graph? When you think about domain, you want to think: is this graph going left to right forever? And these arrows here are kind of here to point out that this thing is going to keep going up and to the left forever, and up and to the right forever. So my domain for this parabola goes from -infinity to +infinity. This graph is going to keep going to the left. It's going to keep going this way, and this is going to keep going this way, right, up and to the right. So I can write that as -infinity less than x less than +infinity. This is going to keep going on forever and ever and ever. Okay, side to side. Now think about your range. Am I ever going to have values down here in my negative y's? Okay, the graph doesn't go below 0. Okay, and so we don't have any values in the negative, so we can write this as y has to be greater than or equal to 0. And be careful here. Make sure you put the equal to sign because we're touching 0 here. Okay, we don't have an open circle. We have a filled-in circle. So y has to be greater than 0. So that's kind of like basically what a parabola looks like, or what quadratics look like. You have this parabola shaped here, which is this U-shaped thing, which we're going to talk about in some of the definitions down below. Okay, so now going into what is a quadratic function. Quadratic function is a non move this out of the way a little bit so we can see it. A non-linear function that can be written in standard form. And just as a reminder, what standard form is, you have y equals ax squared plus bx plus c. Okay, so that's the definition of a quadratic function. A parabola is, and I just kind of talked about this, the U-shaped graph of a quadratic function is called a parabola. The parent function is y equals x squared, or f of x equals x squared. The vertex of a graph is going to be the highest or lowest point of the parabola. And your axis of symmetry, last definition here, is the vertical line that divides the parabola into two symmetric parts. So now we're going to take these definitions here and we're going to apply them to this following graphs and then come up with some the characteristics of the graphs below. All right, so on this first graph here, and we want to identify the characteristics of this graph. So we're going to do a couple things. The first thing I'm going to do is find, so number one, I want to find the vertex. Okay. And again, we want to find the highest or lowest point. Okay. And I want you to think about when will it be a lowest point? And if you look on the graph to the right here, if you see here, we have the highest point. So I want you to kind of think about when is it going to be a low point versus when it's going to be a high point. And kind of keep that in the back of your mind. But right here, we have a low point. And I'm just going to label this point. This point here is positive 2 as my x and my y is negative 3. So 2, negative 3. Okay. The next thing I'm going to do is do my axis of symmetry, which I'm just going to label AOS. Okay. And it's a vertical line. And so with vertical lines, we're going to write an equation that has an x equals. And now we kind of want to think of where is it going to be symmetrical? It's going to be symmetrical right through the middle, right here. Okay, right. It cuts the graph in half, right? And so then what's that x value? It's 2. So x equals 2. Okay. Now, next up, we want to find out when it's increasing versus decreasing. So that's another thing that we can talk about. So once you've drawn this line, it's pretty easy to see. On this left-hand side, okay, this graph, as I'm approaching this vertical line, this pink vertical line, my value is getting smaller and smaller and smaller, right? So it's decreasing. So I'm just going to put it. Okay, it's decreasing when x is less than 2, right? Basically, the way you want to think about this is move your, if you have like a little ruler or a little straight edge, and if you do this, if I draw a little straight line like this, and if I move this along the graph, if I take this guy and move along the graph, what is happening? Is my graph decreasing or increasing as I move along here? If I move this pink line along, right? So it's starting off high and it's getting smaller and smaller and smaller, right? So it's decreasing, and then once you hit that axis of symmetry, and then it starts to increase. So this is decreasing when x is less than 2. Okay. And then likewise, it's increasing when x is greater than 2. So increase when x is greater than 2. Okay. So there's a couple of things that we've done so far. So we've done when is it decreasing, when is it increasing, what's the vertex, and what's the axis of symmetry. The domain is what I'm going to do over here. Domain. Okay, again, think, is my graph moving from side to side forever and ever and ever? It is. So you have negative infinity less than x less than positive infinity. Okay. And my range, think about what's going on here. Okay. Well, think about, am I going to have values in my graph that are below this line right here? If I draw a little line like this, right? Is my graph ever going to be down here? It's not. So my y's have to be bigger than this value here. So y has to be bigger than -3. So y has to be greater than or equal to -3. Okay. Now on the next one, you have something pretty similar. Okay. So again, my vertex right here, highest point, just gonna label it V, and that is at the point -3, 7. All right. The next one, my axis of symmetry, if I draw that in, with a line that goes through here, like so. Again, all vertical lines start with an x equals. So you have x equals -3. Okay, now, again, if I take this, I'm going to take this line here, I'm going to move it around a little bit. So again, if I move from left to right, what's happening? Well, here I'm starting small, and then my axes are getting bigger until I reach the vertex. And once I get past the vertex, it starts to decrease. Okay, so here I'm increasing when x is, so I'm just going to put I, increasing when x is less than -3, and I'm decreasing when x is greater than -3. Okay. Now my domain, I'm going to put DO for my domain. Okay. Again, is this graph moving to the left forever? Is it moving to the right forever? In this case, it is. So -infinity less than x. I'm going to do it on the next line, and then positive infinity. And then my range, think about that. Okay. Am I ever going to have y values up here? No, I'm not, because the graph stops here at +7. Because everything below +7 will work. So my range is y has to be less than or equal to +7. Okay. Now, moving on to the next page. So now we want to kind of graph some of these and look at some of their transformations. So I'm going to make a quick XY table here on the first one, and then we can kind of take a look at what's going to happen. So I'm going to graph, or I'm going to make a table first. All right, so here I'm just going to put the first column, I'm just going to put x's. Okay, now I'm going to put the parent function. So here I'm going to put y equals x squared. And then the last one, I'm going to put y equals 2x squared. So I'm going to put the actual graph that we want to do. 2x times 2 squared. All right, so we kind of talked about this already. You have 0, 1, -1, 2, -2. Right? When x is 0, if I plug in 0 into this, I get 0 squared, which is 0. 1 squared is 1. -1 squared, which is also 1. 2 squared is 4. -2 squared is also 4. Okay. Now, if I do the same thing and I think about order of operations, I do the exponent first and then I do multiplication, right? So if I plug in 0, I have 0 squared, which is 0, and 2 times 0, which is also 0. Now to the next one. 1 squared is 1. 2 times 1 is 2. Okay. Now do the next one. -1 squared is +1. +1 times 2 is 2. Do the next one. 2 squared is 4. Okay. 4 times 2 is 8. Okay. You might see a pattern here. -2 squared is 4. 4 times 2 is 8. So now compare each one of these values. Look, now if I take a quick little look at these, go across here, what do you notice here? All I've done was doubled my value, right? So this right here is that vertical transformation that we've talked about before, right? And what this is going to do is going to make the graph skinnier. And I'm going to graph it here in a second. You'll kind of see that. Okay, so if I put some axes on this graph, this. All right, so I'm going to graph the parent function first, and I'm going to do, so I'll do the parent one in pink, and I'll do the new one in green. So 0, 0, 1, 1, negative 1, 1, and then 2, 4, 1, 2, 3, 4, and on the other side right here. Okay. So again, symmetrical. So once you kind of see half, you can kind of see the other half pretty easily. So you have a graph of something like this. Okay. Now, if I do the green one, okay, so 0, 0, that stays the same. Instead of 1, 1, I have 1, 2. So I have a dot here. And then I have negative 1, 2. And then I have 2, 8. So then 1, 2, 3, 4, 5, 6, 7, 8. And then 8 on the inside here. Okay, so now I have a graph that looks like this. Okay, so it gets skinnier because of this vertical transformation on the inside. Okay, it's called a vertical stretch. Think about stretching your arms out on top of your head, right? As you stretch further and further, it gets closer and closer to your head, right? That's kind of how a good way of thinking about it. Okay. So now with that information, now think about the next one. Okay, now if I told you forget about the negative for right now, so kind of cover this up for right now. What's that 4 going to do? Well, it's kind of very similar to this one, but the number's even bigger, so it's going to get skinnier and skinnier and skinnier. Okay. Now, if I put that negative back, think about what that's going to do. Well, negative is a reflection, so it's going to flip it all over. Okay. So if we made an XY table, okay, you can use these numbers here. This is going to stay the same. This is our parent function. Okay. So I want to compare to this guy. Well, all I'm going to do, I'm just going to make a little column here. So negative 4x squared. Okay, so now think about what we did over here. We multiplied all of our y's by 2, right? We took this number and multiplied by 2. Took 4 and multiplied it by 2. Okay, now we're going to do the same thing, but instead of multiplying by 2, we're going to multiply by negative 4. So we're still going to have 0, 0. Instead of 1, 1, we're going to now have 1, negative 4. Okay, same thing on the next one. You're going to have negative 4. And then instead of having 2, 4, we're gonna have 2, negative 8, and negative 2, negative 8. Okay, so if I graph these now, I'm gonna use the same parent function. So I'll do the same color. I'll do that in pink, and then I'll do the other one here in green. So I've got this graph. If I do the parent function, or sorry, the parent function was in pink. So 0, 0, 1, 1, 2, 4. 1, 2, 3, 4. So you have this pink one here. Okay. Now if I graph this one over here, again, I'm using the same x's. So now 0, 0, so that stays the same. But now instead of 1, 1, I have 1, negative 4. So 1, 1, 2, 3, 4. Okay, same thing on this side. And right away, you can see without even having to put a second point, this is a lot steeper, right? The slope is a lot steeper, and it's reflected over the x-axis here. It's flipped it all over. So you get a graph of something like this. So it's made it steeper. Now, again, you can kind of think about it, and then I'll give you a second. If you think about now, if it's a fraction, well, if it was a whole number, okay, a number bigger than 1, right, it made it steeper. So then think about what's going to happen if it was a fraction. Okay, you can probably guess it a little bit. It's going to get a little fatter, right? It's going to get wider. Right, the slope is getting the slope is smaller. So we'll kind of draw these out here, and then you'll see. All right. So. And again, think about this. Whenever I talk about transformations, I think about it in parts, right? We have a change of slope here with the 1/3, and then we also have a negative here, right? So that's a reflection. So we're doing 2 different transformations. So if you I'll draw the same table again. X squared, and then negative 1/3 x squared. Okay, 0, 1, negative 1, 2, negative 2. Okay, so then 0 squared is 0, 1 squared is 1, negative 1 squared is 1, 2 is 4, negative 2 is also 4. Okay, again, order of operations tells us do the exponent first and then multiply by this number in front. So now all I gotta do is multiply the second column here by negative 1/3. So I get 0, negative 1/3, negative 1/3, negative 4/3, and negative 4/3. Okay, so now if you draw this graph, so you see how all my positive values here now turn into negative. So there's your reflection. And then you're going to see it's going to be a little bit wider. So let me put this in. So I'll do pink again, same color for the parent function. 1, 1, 2, 1, 2, 3, 4. And then 1, 1, 2, 3, 4. Here, graph like this. Okay, and now do the same thing on the next one. Okay, 0, 0, so that stays the same. Okay, and now I have a 1 comma negative 1/3, which is going to be like somewhere in here. And then same thing on the other side. And then I have 2 comma negative 4/3, which would be somewhere like this. Okay. Now, if I graph this one, you're going to see how much wider it is. Okay. So then you have a graph that looks something like this. Okay. So I'll let you try the last one on your own. Again, try to set up those different parts, but I want you to think about what's this 1/2 going to do, right? And it's a positive 1/2, so are we going to have a reflection? We'll kind of leave that one off to you guys, and we'll kind of talk about it in class. But that's it for this video, kind of looking at some characteristics of parabolas and quadratic functions, talked about domain and range, when it's increasing and decreasing, and kind of what some basic transformations here at the beginning. So if you guys have questions, as always, let us know, but enjoy the rest of your day.